Hello, Prof. Lin. Are you there? Assalamualaikum, Pak Syaril.
Kiki, sebentar sedang men-set apa?
Oke, Pak.
Udah nyambung Pak Ki?
Halo, Pak. Lah nyambung, Pak.
Dah ya.
Ini Prof. Lin juga udah bergabung sama kita, tapi mungkin belum hidup kameranya. Masih 39 peserta, kita tunggu lagi dulu, Pak.
Hello, this is
Hello?
Professor Lin. Yeah, this is Professor Lin from Taiwan. How are you?
Okay, Professor, how are you?
Can you hear me?
Yes, I hear you.
So it is clear. Okay, that's good. So nice to see you. And how many audience will attend this conference?
Actually, we have 300 audience registered in our registering, but now still 42 audience.
Oh, I see. Great. It is a very nice opportunity to meet together by this way. And I hope we can enjoy this 2 hours.
Yes, sure, Professor. How about there in Taiwan? Is it okay?
Yeah, the weather is nice today and these few days, and maybe in the next week will be cooler. Yeah.
Oh, yeah. Is it my voice clear, Professor?
Yes. Sure. It is very clear. Yes.
Alhamdulillah. We will happy that you can join in our symposium today, Professor.
Yeah, this is my first time, and I try to have. I believe this will be an excellent experience with the discussion with more. I think that all the audience are coming from the students, the master students in the school or undergraduate students.
Okay. Actually, Professor, we also have Mr. Kismadinata for joining, but however, he has another assessment today. Mr. Kismadinata is a head of a Center for Energy. Actually, he wants to join with us. I see in your. Actually, in your CV, I also read that you are director for the research institute, research energy. Is it right?
Yes. Yeah, we have a research center on energy technology and strategy. Actually, we are quite active in different kinds of energy research. Yes. Yeah, including the wind energy and also bioenergy. I will present today. And also we try to think about for the future goal, especially on zero emission in 2050. You know, globally people try to focus on carbon reduction. Actually, this is a new area we will jump in. Yes.
Maybe later we will continue our discussion on research study. Actually, Professor, for your information, our journal Teknomekanik is under Scopus assessment. So today our symposium is part of our strategy to be can be assessed by the Scopus in the next period. So I hope your articles can increase our journal, and also your contribution in our journal.
Sure. Well, I think this is today's topic is more focused on biomass, but later on we will have a more possibility to to discuss different kinds of field. For example, I just mentioned wind power, or maybe we can go for more deeper for biomass application. And now we more focus on the the hydrogen energy use for ion making.
Oh, hydrogen energy.
Yeah. So there is so many different aspects we can work together later on if you are interested in.
So pyrolysis is just a little bit area in your research area, Professor?
Yeah, this is one of the area. One of the areas. Not, we have so many.
Just
in our research center, we have 11 PhD researcher and also have 30 research assistants. Yeah, we have we are a big research center, and we working on different research projects from government and also from the industry side. So
the research center is under university or under government, Professor?
It's under university, but actually we are quite independently handling the project because we apply the project by ourselves. Okay, and we got funding from different resources, and we just pay sometimes somewhere is a 10% or 20% control fee to the university. Yeah.
Oh, this is obligation for paying to the university from your research grant in your research center.
Usually we got a small funding from the university, but basically because we have some facility and those facility built up in the previous years, and some part of them supported by the school. Actually, we still have a strong connection with the school, but financially now we are quite independent. The management, yes.
It's almost 12 years, right, Professor? Your research center has built.
Yes, 12 years. Yeah,
12 years. What a long journey, Professor.
How long, my? Excuse me?
It's a long journey to develop the research center from 2008. Your research center.
2008, yes, it's pretty much earlier. Actually, our research center was support initiated by the top tier university project from the Ministry of Education in Taiwan, and those funding coming from the first 5 years. After that, we try to be independent. Then we grab the research grant from different resources, and now research center is being more self-sustained. And in these 5 years, actually, annually we got the tens. No, let me see. Oh, I don't how to. 10 million. 1 million. No, 10 million. We can we have a research funding 10 million new Taiwan dollars each year. Yeah, in recent 5 years. This is a big funding from gathering from different resources.
For only the energy, or you have any energy?
Yeah,
especially for wind energy or others energy resource, Professor?
We have a different area. Wind energy is one of the major tasks we have. The other one we are dealing with the building, green building. Okay, and we have the other one. This is more important in our research field is combustion. And those combustion techniques were applied to the biomass or to the fossil fuel. Okay, and the other one is now we are working on the smart grid and including the artificial intelligence. We try to apply the artificial intelligence techniques to manage the energy systems. So big data analysis and also artificial intelligence, it becomes more important, and the target in next 5 years in for our research center.
I think there's a small connection problem.
Good. They have connection problem.
Hello, Professor.
Yes, yes.
My connection. I'm sorry, my share is unstable.
It's fine. Yeah, I hope the actually I should send the PowerPoint to you yes, maybe send but I already modify it. But later on, yes.
Yeah, it's nice if our university research center can join and also collaboration with your research center, Professor, in the future.
Sure. We try to find the opportunity to meet together, and we have some discussions, and I try to introduce our research center to you, and to see how it is very strong possibility we can work together. You know, the Ernest in my group, Ernest, he is my PhD student, and actually he is one of the authors for this paper. I asked him to try to put our previous experience experiment result together as this a little bit like a review paper to present in this symposium. Yeah. So Ernest is a good student and come from Indonesia. And I hope, he will graduate very soon. Hopefully.
Terima kasih Pak Anas. I should grateful to Mr. Anas. Terima kasih Pak Anas.
Yeah,
because the time is already 2 o'clock in Indonesia, 2 p.m. in Indonesia. Can we start the symposium, Professor?
Sure. I'm ready.
Okay. May I have your attention, please? The audiences, we will start our symposium in shortly, and please mute your microphone to avoid the interruption during the presentation. Okay, we will start. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh. Your Excellencies, Rector of Universitas Negeri Padang, Dean of Faculty of Engineering, Dr. Fahmi Rizal, Head of Department of Mechanical Engineering, Mr. Purwantono, Head of Research Institute and Community Service, Mr. Yohandri, PhD, Editor-in-Chief of the Teknomekanik Journal, Prof. Syahril, and the Honorable Speaker, Professor Ta-Hui Lin, lecturers, fellow students, ladies and gentlemen. It is my happiness to be an MC and moderator for the 3rd symposium organized by Teknomekanik Journal, Department of Mechanical Engineering, Faculty of Engineering, Universitas Negeri Padang. I am Sri Rizky Putri Pirmandari, PhD, but you can call me Kiki. On behalf of Teknomekanik Journal and the committees, I would like to welcome you all to this symposium. We appreciate you joining us in the middle of your busy schedule. We hope you enjoy this symposium. To opening this symposium, we are pleased to have Professor Syahril, PhD, Editor-in-Chief of Teknomekanik Journal, to deliver the opening speech. Professor Syahril, are you ready? Please, time is yours.
Thank you, Rizky.
Yes, sir. Please, your time is yours.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. The Honorable of Rector University Negeri Padang, Prof. Ganepri. The Honorable to Dean Faculty of Engineering, Dr. Fahmi Rizal. The Honorable to Head of Mechanical Engineering Department, and all lecturer, staff, and committee. Special one, our speaker, Prof. Ta-Hui from National University and National Cheng University of Taiwan. Thank you, Mr.
Thank you.
Prof, for your sharing knowledge. I am Sahril, Chief Editor in Chief from Teknomekanik Journal. And all attendants, ladies and gentlemen, first of all, let us thank to Allah who has given us His blessing so that today we can see each other virtually here to join this event. I give my big thanks for and appreciation to committee who have working hard to hold this symposium. This event is the third international symposium, which is presented by Teknomekanik Journal, organized by Department of Mechanical Engineering, Faculty of Engineering, sponsored by Research Center University Negeri Padang. For information, it's an international journal which is dedicated to improvement and disseminate of knowledge and method, policies, technologies, and technical science and vocational education. It welcomes contribution from all who wish to report on new development and latest finding in engineering, new trend, and progress provide practice in list, in file, task creating in unique forum for interdisciplinary or multidisciplinary knowledge. Teknomekanik Journal published 2 issues in year, and it has been indexed by Ta-Hui, Google Scholar, Garuda, and Dimension. So, for everyone who has qualified article with this area, please send to Teknomekanik Journal for publication. Ladies and gentlemen, this symposium will have an outstanding speaker from National Cheng University, Taiwan. Professor Ta-Hui will present his paper entitled Utilization of Sewage Sludge using multiple thermal conversion process. The paper contains updated knowledge, so we can get new input and understanding from it. So everyone, please follow this symposium well and take a good advantage of the question and answer session. Last, I am as the editor-in-chief of Teknomekanik Journal, once more would like to welcome you all in this international symposium, and we wish this event will be benefit to everybody. Now, I officially open this symposium by saying Bismillahirrahmanirrahim. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, sir, for opening the symposium officially. Okay, ladies and gentlemen, next, the main session of this symposium is presentation from our invited speaker. Keep your question until we are in a Q&A session. The audiences could give the question through chat column during the presentation by stating your name and your affiliation. However, before the presentation, let me introduce to you our speaker, Professor Dr. Ta-Hui. Okay. Professor Ta-Hui is currently the Distinguished Professor of the Mechanical Engineering Department and serves as the Director of Research Center for Energy Technology and Strategy in National Cheng University. He is the principal investigator since 2016 of the program on the talent cultivation for the integration and application of clean energy system. Okay. The CV of the professor can be seen in my screen. His research team recently received the 7th National Industrial Innovation Award, Innovative Trailblazer Team Award 2021 from Ministry of Economic Affairs, Taiwan. His research interests include basic and applied research on combustion research related to energy utilization, air pollution control, and fire protection, and offshore wind power. He published over 500 research papers, including 142 international journal impact in Scopus. He has 22 patents and 3 technology transfers. 15 PhD students and 128 master students completed their thesis under his supervision. Please welcome our speaker, Professor Lin, to present his topic on utilization of sewage sludge using multiple thermal conversion process. Please enjoy your time, Professor.
Thank you. Let me share my screen. Can you see the slides?
Yes, clearly, Professor.
Okay. Thank you so much. It is my privilege to have this very nice situation to communicate with all of you and present our recent results on biomass studies. Before my talk, I would like to thank Professor Sherry, Editor-in-Chief, for this symposium and journal, and give me this opportunity to share our research finding with you. And I also thank for the Kiki for all the arrangement for this presentation. Now I start to deliver the talk by using these slides. Okay, my title is Utilization of Sewage Sludge using multiple thermal conversion processes. And actually, those kinds of experimental observation and actually performed by my students, Ernest Forges, and my 2 colleagues, Dr. Cheng and Dr. Fangxuan Wu. Actually, those results coming from our research center. Now, in this talk, we will cover, initially, I will give you some introduction on the background and the objective of our this research, and we will introduce some methodology for the pretreatment of the sludge, and also try to give it some understanding on how to produce the pyrotic oil from the sewage sludge, and we will check the combustion characteristic of the blended fuel of sewage sludge, pyrolysis oil, and heavy fuel oil. Finally, we will have some introductions on co-gasification from our experimental products, experimental results. Then there is some results and a discussion will be presented. Finally, I will give you the conclusion. The first section of introduction, basically, when I think recently, in all over the world, actually, people talk about the carbon reduction, especially the main target to the 2050, people try to eliminate the carbon emission down to 10 gigatons compared with recently we have a 32 gigaton CO2 carbon dioxide emission. This is a big target for us. And how to reduce the carbon emission? Actually, the burning the utilization on renewable energy will be the big task. People will think about the two major renewable energy, means the wind energy and also the PV. They will be the most important two renewable energy to be achieved to reduce the carbon dioxide reductions, carbon dioxide emissions. But the second position, actually, we need to think about the bio waste utilization. Since bio waste utilization is spread all over the world in different kinds of situations, here I try to give you the understanding where we can have the bio waste. For example, from the forest and the wood processing, agriculture and our industry, and even in the city, we have so many different kinds of waste and animal waste, and also from the food processing and the paper industry. Those different resources will provide different kinds of biomass. When you have those kinds of biomass, or we call bio waste, people usually up to now, they will use the two different kinds of methods, try to convert the original bio waste to use for different kinds of fuel and for further application. The technology can be divided into two major tasks. The first one is a so-called biological method, including different kinds of digesting, translocations, fragmentation. Even they can use the so-called microbial fuel cells to produce the end products. Maybe you can have biogas, biodiesel, bioalcohol, or electricity. Okay. The second category for producing the useful products, basically coming from so-called physical chemical method, including the pyrolysis. This is the topic I will dealing with in this presentation. Through the pyrolysis process, you can have the charcoal, bio-oil, or biogas, and those can be used for transportation or for the burning in stationary boiler, something like that. The other one is the gasification. We try to gasify your wild waste to produce the syngas. The composition for syngas usually focus on carbon monoxide and hydrogen. Sometimes you may have a certain amount of methane, and those components, the syngas component is easier to burn, and they usually have a less carbon dioxide emission compared with the coal or petroleum. And the third one, incineration. Incineration means you do not go through the different kinds of pretreating process, just put it into the combustion process to generate the heat. Okay. And the fourth one is a hydrothermal carbonization to produce a solid biomass. We call this as a charcoal. And the final one is landfill. This landfill basically has produced some trouble. Later on, I will mention a little bit. Then they can produce the methane, and sometimes they usually produce carbon dioxide. And this is an overall picture to tell you where you can have the bio waste and how can we convert bio waste to the bioenergy through different kinds of technology. Now, we try to focus the target of our so-called sewage sludge. Sewage sludge usually produced from the water treatment department in different kinds of company. And there is a summary on the sludge productions for different countries. You can see from these figures, you can let's look at the production per year. You can see there is a large amount of sludge production by China and USA, because they are big company. and they have a large population. They will have a large productions for sewage sludge, and they can have 6 million tons per year. I think Indonesia still have a certain amount, maybe big amount of sewage sludge productions, but in the literature we cannot have this data. Maybe you can check it. I think you have a potential to think about how to use the sewage sludge to produce the energy. But in different kinds of countries, actually they try to dealing with the sewage sludge or those bio waste by different methods. Here in this plot, you can see you may go through the agricultural use, or you may go to the incineration, or you can go through the compost or landfill. Now, I just give you some understanding for different kinds of application. If you regarding the agricultural use, sometimes you need to think about, usually the sewage sludge contains the pathogenic bacteria and the virus and parasitic hermits, which can harm the health of the humans, animal, and the plants. They have a disadvantage on human health. But for incinerations, usually you put the waste, you put the sewage sludge into the combustion chamber, but always the sewage sludge contains a certain amount, high amount of water in it. The heating value are very small. Then the application purely through the combustion process actually is not a good choice. But for the landfills, when you just put it sludge, put it on the lands, and because they contains a certain amount of organic substance, they will through the automatic pyrolysis, then will generate a certain amount of methane, biogas rich in methane, and you will have produced some dangerous in making fire on the land. And sometimes people, the other problem is the cost for this approach is also increased, because you cannot find appropriate areas for landfills. Which means if you consider those kinds of opportunity to treat the sewage sludge, then you will figure out that the last one, thermal-physical process, may be the good choice, because since go through the pyrolysis or gasification, you can produce energy from the sludge and have a little influence on the environment. This is the target for our study. We try to use the thermochemical process. In this study, we consider the thermal pyrolysis and also gasification to produce the biomass energy. And I try to give you some understanding and an example to let you know how to do it. Okay, now based on the physical chemical processes, we look at the biomass in thermochemical conversion. Depends on there is 3 parameters you need to consider. One is in the process, the temperature becomes one of the controlling parameter. The other one is the oxygen supply. Okay, based on this, the temperature range and the oxygen supply, you can have a different products as shown in the left vertical axis. Let's give you some discussions on it. The first one, if you just try to supply enough oxygens and then make it go through the combustion process, in this kinds of thermochemical combustion, basically we call this as a combustion process. In this process, the temperature are pretty much high, from the 900 to the 1500 degrees Celsius, and they just convert your energy to heat. Okay, you will release heat directly. This is maybe related to the so-called the combustion process. The second one, you reduce the oxygen supply. That means that you do not want to have a complete combustion for your gas or your sludge, but you try to make it as a gas. The product will be the syngas. In this process, they will go through the temperature range between 600 to 1300. And there is the 3 different kinds of gasification process. One is the so-called conventional, which one is presented in this in my report. And there is a steam gasification. They use a steam as a carrier gas. And the last one is the supercritical water gasification. Okay, they have a different kinds of processes, but finally they will produce a syngas for future use. If you lower the temperature range up to 260s, and in this way, you just simply to make your sludge to become liquid. And we call this a so-called liquefaction, but actually this is quite expensive. People do not use these techniques as usual. Now, if you go through the oxygen supply, try to reduce the oxygen concentrations, then you can have a chance to produce a so-called bio oil, bio liquid. Okay, this is mainly will be described by the so-called thermal pyrolysis. You can have a different kinds of pyrolysis by using different catalysts or using different kinds of temperature range. In this process, the temperature range is around 400 to 800. Okay. Now, finally, the last one is actually we produce the solid biochar. Okay, and then in these situations, you do not supply too much energy. The process will be controlled in a lower temperature and in the range of 200 to 600. Then we call this a so-called the torrefication. If you increase the temperature higher, then we call this as a carbonization. And for the solid biochar, actually they just get rid of the liquids, and you have a solid products. This is a briefly classification for biomass thermochemical conversion. Now we go to our objectives for this study. In this study, we try to give you some understanding about 2 important process involving with the physical chemical process. The one is we look at the pyrolysis problem process for the pyrolytic oil. Okay, we produce the sludge pyrolysis oil. The name I use the SPO shortened name here. And we try to use it to mix with the heavy fuel oil frequently used for the industry, and to see their combustion behavior, which means in the first step, I will tell you how to make the sludge pyrolysis oil. Then the second step, I will dealing with the behavior, because these products will mix well with the heavy oil, and then we want to see do we have any advantage by this kinds of co-combustion on this blending fuel. And the third one, I try to introduce the gasification of the sludge, the shear sludge. Since the shear sludge is usually thermal content is relative, not too much, and you need to mix with the different kinds of biomass. And here we use the PKS pound kernel shear to mix together, and to see the final result for the syngas you may produce. For the syngas, actually we will more focus on the carbon monoxide and hydrogen for our further use. Therefore, there is 3 objectives, and I will focus in and give you a short introduction on it. Now, in the studies, we use different kinds of methodology and also equipment. I will just introduce very briefly for you. The first one, we need to dealing with the sludge pretreatment. This figure A, actually, this is original pictures for the shear sludge taken from the wastewater treatment plant in Taiwan. And we usually have this supplement from the Tainan city government. Before we go through the gasification of pyrolysis, we need to get rid out of the water from the sludge, because when you do some analysis, you will find out the original sludge from the plant, they always have a water content higher than 30%. Those moisture, you need to heat it up and try to reduce the water content. This is the first step you need to prepare. Okay, how to do it? Actually, we just preheated the sludge to the 110 Celsius, and then the moisture will reduce below the 10% of the total weight. Then later on in our presentation, you will find out all the sample for the sludge. Usually, they has water content less than 10% of the total weight. Okay, now there is two important equipment used for our study. One is the thermal analyzer for the TG analysis, and also differential scanning calorimetry. And you can use this instrument to analyze those kinds of weight change by the heating process. And usually, when you're dealing with the sample we use, and we use a standard weight for different sample test. There's 20 milligrams, okay, and the heating rate was 10 Celsius per minute, and the gas flow rate was 50 milliliter per minute. And temperature range was 30 to 1000, and those conditions used for our TG analysis. Okay. Now the next step, I will tell you how can we do the thermal pyrolysis for the sludge. This is a typical figures for our system. There is the furnace, okay, and we put the 90 grams of the dried shear sludge as a sample and package it in a cylindrical holder and put into the furnace, okay, and those holders made by the quartz, then actually they can retain the high temperature situation in the furnace, okay, and the heating process is very important. And from the heating process, you will find out 4 control parameters you need to identify. Look at this, the temperature variation for the pyrolysis process. The horizontal axis represent the time, the heating time. We put the sample into the furnace and start to heat the sample, and the temperature will increase. Okay, and the horizontal, the vertical axis represent the temperature you will experience in the furnace. Okay, now in the earlier stage, the step 1, usually the furnace should be heat from the room temperature to the pyrolytic temperature. Later on, in step 2, the pyrolysis process will occur in this step. Then your pyrolytic temperature will keep the same constantly and continuous to the end. Okay, and if you count the time start for the to fixed pyrolytic temperature until the end of your process, then we call this as a residence time. Okay. And in the process, we introduce the nitrogen as the carry gas for the pyrolysis. Then this is the other factor you need to consider. Then if you go through these experimental procedures, you can identify there is the 4 parameters you need to justify and try to evaluate the weighting on the production of the sludge oil. Here, A is the heating rate. Okay, and the heating rate you may increase. That means the time for the step 1 becomes shorter. If you produce a lower heating rate, the time required for step 1 will longer. Okay, and the B is another. The pyrolytic temperature is very important. Residence time is another one. Finally, nitrogen flow rate will be considered. That means that we have a 4 control parameter. You need to examine those effects. And from the experiment, since you have 4 parameters and you try to vary the quantity of these 4 parameters, then make the whole experiment very complicated. Now, people usually for those kinds of experiments, usually a very famous so-called touch method. Ta-Hui method, they try to use the idea of the so-called the signal to noise ratio to identify the quality characteristic of deviating from the desired value. That means if you have a target value and you try to change your parameter based on those kinds of variation of the parameter change, then you can identify which parameter, the weighting for your parameter can be justified, and you will find out the optimal situation for different parameters. For this experiment, actually, we designed 16 experimental sets, 16 experimental sets based on 4 controlling parameters. Later on, I will give you the list of the quantity of each parameters. And for the set of experiment, usually we repeat 3 times and take the average value to make sure all the quantity, all the physical properties is under control. And the last one, we will not the last one. The next one, we will study the combustion characteristic of the oil we produced and mixed with the heavy fuel oil. And we just simply use the single droplet burning apparatus. Here, there is the heating plate. We have 2 parallel heating plates, and we use the electrical heating and to change the environment between these 2 plates as vary from the 500 degrees Celsius, 550, and 60. There is a 3 hot temperature environment. And we try to test the different kinds of blended fuel. The blending ratio range for the pure heavy fuel oil, 20%, the sludge oil up to the pure sludge oil. And we try to think about the influence coming in the blending ratio, and to think about the participation of the sludge oil. How is the advantage for those kinds of mixing burning? Okay. And how to do the experiment? Actually, we do the droplet burning experiment. We use a thermocouple. This moving thermocouple, you will have a still. We just attach droplets. Those droplets around the diameter is around 1,000 millimeter attached to the thermocouple, and this thermocouple can be moved into the regions between these 2 plates. And since the region in between these 2 plates are very hot, that means the droplets, when they move into the center of the region, they start to be heat. When in the heating process, you will see the combustion behavior occurs. Later on, I will discuss with you about those detailed processes. But anyway, you understand how to do the experiment. There is the 2 heating plates, and we use the thermocouple has a suspended droplet to move it into the center of the region, and we start to take the pictures, continuous pictures, using the high-speed camera to see the variation of your droplet until the burning of your droplets. These are blended droplets. Final sections, we were dealing with the gasification process. This is the apparatus for the gasification process. In the left-hand side, this is a supply of your sludge with the PKS. Okay, they are solid, and we can continuously feed into our chamber. And here, this is a fluidized bed. Fluidized bed means that on the bottom of the furnace, actually, there is the bed materials. We use the quartz sand as the bed materials, and there's the size range from the 250 to 300 millimeter. Okay, and we add a certain catalyst. We use the olivines as a catalyst, and they range from the 0 to 25. This is a very the catalyst play a very important role for the gasification. And here, from the bottom, we supply the carry gas. Those kinds of gasified agents, including the carbon dioxide. Here, we can supply carbon dioxide, and maybe we add certain amount of nitrogen, and accompany with the steam. Okay, usually for gasification process, the amount of steam plays a certain important role. And those water, actually, they will get involved with the gasification process. And those from many literature, you can learn through it. Those gasifying agent will flow through those kinds of distributed plate and push the bed material upward, flowing upward, and those sludge and also PKS, they will have start to have some gasification process. Then the syngas will flow outward, upward, and go through the filter. Later on, we do the measurement for the gas analyzers. Finally, they will go through the burner and burning out. Okay, in this process, then you can do the measurement for the final composition of the syngas you produce. And for this experiment, simply the same. Similarly, we use the tactical methods to identify the optimal parameters for generate the syngas through the sludge and the PKS. Okay. Now I finished the introduction on our apparatus and the methodology. Then I try to give you some understanding on the results. And the first one, we need to think about the properties of a sludge. Usually for sludge, it's the so-called multi-component. As you treat the multi-component, means you have a different kinds of components that mix together. Those components will have a different boiling points or for gasification, which means, for example, for the sludge, you have certain amount of water. When you put a sample of your sludge into the furnace or into the oven for the thermal in the thermal analyzer, then you will see the water, the moisture will be evaporated first. Okay, then the lower boiling point materials will gasify later, and by this kinds of process, the boiling points, the lower boiling point will be go out first. Then the weight of your sample will continuously reduced. Okay, the idea is like this, and I give you some understanding on the introductions to our results. This is a TG analysis. The vertical axis represents the weight of your mass. Okay, the weight of your sample. Initially, you have a 100% weight. You use the major weight divided by the original weight. Then initially, you have 100% weight, right? Now in the process, because you go through the heating process from the 30 degrees Celsius up to 1000 degrees Celsius. In the process of heating, actually you can see for this line, for this pink line, they tell you the weight. The weight percentage is continuously reduced, right? This is truly show you there is something, there is some materials inside of your sludge gasify or vaporize, okay, in the process of heating. Now, people usually try to identify the period of the heating process by the slope of the weight variation. For example, you take the line of TG with the differentiation, then you can have the slope shown by the blue line. Okay, blue line represents the slope. You can see the units. They say the weight percent per minute. Okay, because you divide by the time. Therefore, you can see the slope variation like this blue line. Now, the people usually define the big change of your slope, the slope of the weight loss, then identify the different stage. Okay. Now, how to look at it? From the blue line, you can identify for the heating process on sludge. They can be divided by 4 stages. Okay. The first stage from the 30 degrees Celsius to 200. 30 basically from the beginning up to the 230. Here you can see there is the peak of the slope. Okay, in this region we call this the first stage. For the sludge, this stage actually is the removing the water or organic with lower boiling points. Okay, they are easily, because the boiling point is quite low, those material will be evaporate very fast. Okay, and you can see there is a reduction on the weight around 10%, right? As I mentioned earlier, originally your sludge come from the Victoria. They have at least 30% water, and we already go to the heating process to get rid of the 20% water out. We still have a 10% almost remain for our sample. From the test, you can see this. We can have some confirmation on the water content or lower boiling point materials of around 10%. Okay. Now we go to the second stage from the 273 degrees Celsius around here up to the 320 up to here. There is a big change for the slope, and we identify this the second stage. In this stage, there is around 30% of the original sludge is lost, because this is caused by the decomposition of aliphatic component, protein, and carbohydrate contained in the sludge. And those composition basically contains at least 1/3 of the overall sludge. Okay. The third stage, you can figure out there is the big change for the slope of your weight loss. Then if you go further up to the 500, then you will go to the decomposition of residues of organic matter and the inorganic matters. That means there is some carbonates. Okay. And the residues is about 46.79% of original weight still left. Okay, here you can see if you continuous go through the 1000 degrees Celsius, you can see they still have around 46.79% original weight left. That means that this residues you cannot make it gasify. This plot tells you the nature of the multi-component compositions for the sludge. Now we try to put our sludge sample into the production for the sludge for the pyrotic sludge oil. Now we talk about how to do the experiments, and mainly we have 4 control parameter. One is the heating rate. Here, I did put on the table, you can see there is a 16 experiments set up. Okay, and for each experiment set, we will refer to different control parameter, depend on 4 control parameter. One is HR, means the heating rate. The other one, T, is the pyrolysis temperature, and the residence time is RT, and N2 represent the nitrogen flowing rate. You can see from this table how many control parameters vary for different experiment sets. And those, for example, I tell you, for the heating rate, we choose the 10 Celsius per minute, 20, 30, 40 as 4 different labels. For the pyrolysis temperature, we vary from the 450 to 600 by changing 50 as a step. Okay. Now, by these kinds of consideration, we put the whole experiment finish, and we use the Ta-Hui method to identify the value to justify to find out the optimal compositions operations. You can see here, this tables actually they just give you the conclusion for the variation for different controlling parameter. For heating rate, you have a label 1, 10, 20, 30, 40. Okay, as I mentioned, for the temperature, you have 450, 500, 550, and 600, and so on. And by going through the Ta-Hui method, they give you the value, the SM value signal to noise value to evaluate the corresponding optimal conditions. Here, if you consider the parameter for A, B, C, D as shown in the upper tables, the result tell you, for example, for the current for the heating rate, you will see there is the minimum value for our identification of optimal pyrolysis condition. For the case A is the L1, they show minus 21.27 is the smallest compared with the L2, L3, and the L4. That means this tells you for the parameter of heating rate, the 10 degrees Celsius permitting heating rate is the best control. Then which one? This one we will choose it the optimal control factor for heating rate. Similar way, you can see, for example, for the parameter C, residence time, you will find out minus 21.32 compared with the L1, L3, and the L4. This is the lowest one. Okay, then we can choose this as the optimal factors for residence time. Based on these kinds of identification, now we can find out in the production of the pyrolysis oil, the best choice to produce the low oil is the heating rate of the 10 degrees Celsius per minute, as I mentioned here, and the pyrolytic temperature of 450 Celsius, a point here, label 1, and the residence time is 60 minutes, label 2 here, show for the C parameter. Finally, the nitrogen flow rates will be controlled by 700 milliliter per minute. Okay, this is the process to identify the optimal control conditions for the production of our pyrolysis oil. But we need to double check, then we try to calculate the theoretical maximum pyrolytic oil, and we find that the products will be 0.1044 gram per sample, 1 gram sample. And we try to compare with our identification. Then you find out the experiment result is 0.1019. They are very close, right? Which means the identification on our control parameter through the main source is quite correct, and we can use this condition to produce our pyrolysis oil. Then by these kinds of controlling parameters, we start to produce those pyrolysis oil. Now, when you have a pyrolysis oil, now you need to bring those oil to mix with the heavy oil and to do the combustion and to see the results. Now, since we already finished all the pyrolysis, the process, we still need to justify the products or the composition of your products of the pyrolytic oil. Then we bring our oil to the thermal analyzers to do the TG analysis again. Okay, let's still tell you there is a 3-stage. The first stage is the so-called dewaterization stage. The next one, the stage 2, here this is stage 1, this is stage 2. Stage 2 is the decomposition for your volatile meter with the lower boiling point. The final stage basically is the primary combustion stage. Okay, it is clearly can be identified based on the very significant variation on your weight percent slope. Okay, and one thing I need to mention here, there is the final residues cannot be burned is around 11.60% weight remain when you go through the 1000 degrees Celsius heating. And this is the analysis on the variation of your composition in your SPO, the sludge oil. And because we mix the sludge oil with heavy fuel oil for the burning, we will need to do the TG analysis on heavy fuel oil. And this is a heavy fuel oil result. The most important difference for these two fuels, actually here, you will find out for the heavy fuel oil, the stage 1 disappear. simply say that the evaporation of the water, or called dewaterization, is very short. You cannot figure out from the analysis. Usually for the product or heavy fuel oil, from the oil company, they already get rid of all the water. Then you do not have a stage 1 for the heavy fuel oil. This is a complete different compared with the previous situation, previous stage 1 for the pyrolysis oil. Okay, and later on you still have a stage 2 for the decomposition of the volatile material and the burning. Finally, the stage 3 will give you the primary combustion stage. The residues for heavy oil has a less percentage of weight, is 10.21 compared with that for the sludge oil. Okay, now you understand the composition for the sludge oil and the heavy oil. Then we bring it together and to see how they vary. Okay, and we did different kinds of blending ratio from the 20% up to the 100%, and we did the TG analysis. I will not repeat this again, but I give you the overall results, overall conclusion on this test. We find out in the dewaterization stage increase with the increase in the SPO content. That means that if you have more pyrolysis oil, then this stage will become significant. The weight loss becomes large. This is definitely understand, because when you have a more sludge oil, then you will have a more water contents, and the weight loss will become large. Okay, and this is a typical those kinds of weight loss typically influenced by the water content in the sludge oil. Okay, and the second one is if you have a higher sludge oil contents, you will have more significant weight loss in the earlier volatile decomposition and the burning stage. Okay, which means that if you have a more, since from our previous experiments, the heavy oil contains a more higher boiling points, then the burning or the gasification process at the end of the whole process become more important, governed by the heavy fuel oil in the dewaterization stage, and also earlier volatile decomposition stage, which is basically controlled by the pyrolysis oil. Okay, then the last one, just I mentioned, in the later period, the weight loss increase more rapidly in fuel blends with a higher heavy fuel oil. Actually, tell you the later period is controlled by the heavy fuel oil. That means this is a very clear picture to us. When you mix two liquid fuel together, and you will find out in the process of the gasification, for this case, the sludge oil will control the initial period, but heavy fuel oil has more influence in the later period. This is the result we may have. The detailed analysis will be followed by we checking about the combustion parameters. I just give you the quick observation on the results. Here, there is the two index. One is the so-called flammability index. The other one is the combustion index. We use the data from the TG analysis. Then you can calculate. Basically, it's simple to say that if you have a larger C index or larger S index, that means that in the combustion process, then if you have large C and a large S, then the combustion index is tell you it becomes stronger. Okay. Now the interesting thing you already remember I mentioned when you look at those blending fuel of the sludge fuel, sludge oil with heavy fuel oil, in the process of your gasification, the initial stage is controlled by the sludge oil. And the later steps will be controlled by the heavy oil. Now you can see here. Now there is the index. This L means if you consider the low weight component means if you look at the initial period, the H represent the high weight component. High weight component means those materials as higher boiling point. Low weight component means here we use the abbreviation as a low LWC represent a low weight component. Okay, and the HWC represent a high weight component. And I use L to represent LWC. H represent the HWC, and the difference between these two categories for the materials, the L means that they have a lower boiling point. The occurrence for those kinds of gasification for lower weight components appear in the earlier stage. Okay, and for the H, they will occur in the later stage. Then you can see I give you the red arrow to tell you. When you change here, the SPO, the sludge oil increase, initially is 0. This is a sludge oil. And then when you increase the mixing ratio to 20, initially, I'm sorry, the 0% means the droplet is, the sample basically is a heavy fuel oil, okay? And you increase the percentage of SPO continuously to 100%. That means that if you go through the 0% to 100%, that means that you will have more sludge oil. Okay. By this consideration, you can see for the earlier stage, for the C index and the S index, those both of them are increased continuously. Okay. Tell you the influence actually governed by the SPO. Okay. But for the CH and the SH, for the higher weight components, those effect is just reverse. They tell you the heavy fuel oil 0% is play more important role. Okay, because in the later part, the heavy fuel oil has more importance on the overall gasification process in the later part. Then you can see the arrow reverse, and I show it as a blue arrow line. Okay. And this is a typical evaluations on the combustion characteristics. Finally, you can have the statement here. The SPO, the sludge oil, has better combustion performance in lower weight components period. However, the heavy fuel oil has better performance in higher weight component period. Okay. This is a very important conclusion for the mixing fuel. And later we do the experiment for the burning of your droplet. Actually, these kinds of behavior, since I mentioned, those fuel made by the sludge, they always has a multi-component. Multi-component means you have a different materials inside your liquid fuel. They have a different boiling point. And this is a typical observation on droplet, on multi-component droplet. For example, if you have a multi-component droplet, that means on the surface, you may have a lower boiling point material mixed with the higher boiling point materials. Then this droplet, when they experience a high temperature from the surrounding, the first step, the lower boiling point material will be gasified first. Very soon, they will gasify first. But later on, the surface will be accumulated for the lowest higher boiling point. Since the higher boiling point for the gasification, they need to wait to reach their boiling point, which means there were small periods for the heating. But in this small period heating, then heat still continuous, will transfer into the interior of the droplets. But interior droplets still already contains low boiling point materials. Those low boiling point materials will be gasified inside of the droplet, become vapor. But you know the whole droplet is the liquid. They just a case, and inside of the vapor, they will be forced in a small control volume. That means that the pressure will be built up. those pressure to build a certain value, they will break your droplet to certain tiny droplet, or sometimes those vapor will be inject out. Then we call this a so-called micro explosion. Okay, if you understand those kinds of micro explosion, you can see for a given branded droplet in the combustion process, they can go through different kinds of process, different kinds of stage. May not go through the detailed stage. I just give you some stage you may observe. Okay, follow the series of the pictures. You can see in the beginning they will go to the so-called the surface micro explosion. That means the micro explosion occurs on the surface. They have a tiny droplet inject out. Okay, because they initially they can build a certain vapor pressure high, then they will inject out. But those kinds of injections occurs on the surface of your droplets. Later on, the next stage, the interior micro explosion stage. That means that you can see the droplet size become large. Why the droplet size become large? Because the inside of your droplet, there is a lower boiling point vapor, a lower point material evaporate. They have a certain vapor accumulate and push the droplet become large. There's and the other factor is there is some thermal expansion. Okay. Now the third stage, you can see after the micro explosion, you can see there is a big droplet coming out. When they have some vapor coming out, then droplets become smaller. When they have a smaller, then will stay very steady evaporation process. And finally, they still have the second stage. Micro explosion always, because this is the multi-component materials, micro explosion occurs so many times. Okay, this is some kinds of series. Now the fourth stage, they still have an expansion and a micro explosion happen. And sometimes you may have some fuel vapor coming out, and those fuel vapor is large enough because we did this experiment in the air environment. And the heating plate provide a high temperature enough for ignition, then sometimes you can produce the flame. Okay, those flame occurs in the gas phase, they burn out the fuel vapor coming out. Okay, when you burn out all the fuel vapor, finally you just have a tiny droplet left. They just have a very weak combustion process persists on the surface. This we call this a smaller stage. Finally, the whole combustion process in the gas phase and also the surface complete. Then you just have a residue exist. This is the behavior you can observe in the whole combustion process for a given mixing fuel of the pyrolysis oil and a heavy fuel oil. And from the long-term observation, we find out, I just give you the overall conclusion, okay? They tell you from our observation, because you can measure the droplet size, okay? And those kinds of big fluctuations from the figure tell you actually droplet size is always changed because there is some liquid inject out, vapor inject out, and then the size is sometimes they will expand, sometimes eject out, become smaller, okay? And we find out higher sludge oil content increases the frequency of micro explosion. That means that since we have a lower boiling point for the pyrolysis oil, it is easier to be gasified inside a droplet. Then they will promote micro explosion. Okay, and the residues product of fuel blend with the lower pyrolysis oil, they range in the size. They will just have a 0.63 to 0.85 times to the original diameter. This is the rest residues compared with the original droplet mass. But for the higher SPO, the residues become small compared with the previous one. The previous one I mentioned, if you do not have too much pyrolysis oil, then you will have a larger residues. I just explained because those kinds of pyrolysis oil, they will have a lower point materials to be to produce the micro explosions and to enhance the breakup process and also the combustion process. Then they will give you the opportunity to reduce the residues. Okay, here they tell you if you do not have too much SPO, then the size of your residue is very close to the original one. But if you increase the SPO contents, then they will reduce the maybe just 20% the size of original diameter. This tell you the application of the pyrolysis oil has some improvement on the burning of your droplets. Okay, and we try to do the some so-called D-square law of variation, because from the theory for droplet gasification, if you count the droplet diameter square, it means that we count the surface area of your droplet. You will find out the variation of your droplet surface is linearly decreased in the combustion process. Okay, and we get these results and very nicely to tell you here. If you measure the droplet diameter, okay, non-dimensional by the initial droplet diameter, okay, and try to put your data along with the time scale. Okay, this is a non-dimensional time, which means that when you ignite it and then you measure the droplet diameter and then make it a square, and you can see the variation, especially and when you have a steady burning process, you can see this is a linear line, as I said, tell you is exactly predicted by the D-square law. This is a linear line, and this is also linear line. This is also linear line for a different burning ratio of your droplet. The yellow color represents 100% pyrolysis oil, and 60%. That means that you have a lower percentage of your pyrolysis oil. The rest of it will be the 40% of heavy fuel oil. Okay, and how to look at the burning intensity of the blended fuel? Actually, people need to check about the slope. Okay, if you have this linear line, you can calculate the slope, and we call this so-called the evaporation constant. If you have a larger evaporation constant, means the burning intensity or evaporation intensity is stronger. If you have small one, then the burning intensity or evaporation intensity is smaller. Okay. Now here you can have some justification on the burning intensity by the mixing of the pyrolysis oil. Here you can see if you have a pure 100% pyrolysis oil, the K value is equal to 3.47. But if you reduce the concentration, then you can see the K reduced. This tells you if you reduce the composition of your pyrolysis oil, the burning intensity or gasification intensity will be reduced. Okay, now we go to the final section for gasifications. Since those materials taken from the company for the sludge always composition change, everybody should remember when you repeat when you try to initiate the other project, you need to repeat the thermogravimetric analysis again. Okay, which means for gasification, because we try to bring those waste material together. One is the sludge, the other one is the PKS. We need to do the individual TG analysis. Okay, then we repeat again for a new sample, and you can still see they can divide by the 3 stage. I don't want to explain again. And for the PKS, now you will find out there's some different compared with the previous one. Here there is the 4 stages based on the variation of the slope of your weight loss. Okay. Stage 1, they tell you there is a moisture coming out, okay, similar to the case for the sludge. And stage 2, and stage 3, actually they are basically they are described pyrolysis or having cellulose and cellulose. Actually, the compositions for sludge and the PKS are completely different. They may have a different gasification periods. Therefore, for the PKS, they have an additional stage 4. By this the slope change, you can identify the different stage. And the final stage is very similar. And here there is the pyrolysis ligand. Okay, and now we try to bring these two materials together for gasification and think about to optimize our controlling parameter. As we described previously for the pyrolysis, we still do the similar arrangement. We have 16 experiment sets, and here there is the 4 control parameters. One is the gasification temperature, this is T, and the fuel blending ratio, because we mix the sludge and the PKS, then the blend ratio is the one important parameter. And the third one is very important. You remember, for the gasification, we need to have some gasified fluid. In basically, is composed carbon dioxide and also the steam. That means the water. And this is a key factor for gasification. We need to make it as the important control parameter. CO, the carbon dioxide, divided by the total carbon dioxide plus steam. This is the important parameter you need to identify. The final one is the how much you use the catalyst. Okay, I give you some explanation. For example, for the gasification temperature, we choose 4 temperature. One is 750, 800, and 850, and 900. For the percentage of the carry gas CO2, we choose 50%, 55%, 70%, 85%, and 100. People will ask why you choose this range. Actually, those 55, actually, we find out from the literature, they show you the maximum value you need to consider. If you choose the value, the carbon monoxide ratio lower than 55, maybe the gasification process may not continuously. Then we try to give a suitable range to pick a suitable control parameters. Okay, and in the process, we just mentioned we will use the fluidized beds. In the fluidized beds, we control the flowing velocity. Velocity is around 0.25 meter per second. That means the equivalent to the 5 liter per minute. And the filling rate of your sample is around 0.18 kilogram per hour. Okay, and we still follow the same procedure to calculate the corresponding signal to noise ratio to identify the control parameter. Okay, I just give you the simple results. For the gasification process, you will produce a syngas. The component for your syngas, basically, people will consider the availability for your syngas for future utilization. They will consider 2 factors. The first one, they will consider how much hydrogen you have. Okay. The other one is the hydrogen ratio, hydrogen and carbon monoxide ratio. Basically, the composition for the syngas usually has the carbon monoxide, hydrogen, and sometimes they have a small amount of methane, but mainly the major component is hydrogen and carbon monoxide. Okay, but hydrogen usually has a lower thermal contents, heat of combustion. Carbon monoxide has a higher. Therefore, the ratio between hydrogen and carbon monoxide is an important parameter you need to identify. Therefore, we use these 2 factors to justify the control parameter from our gasification process. Okay. Similar way, if you look at the ratio between the hydrogen and the carbon monoxide productions, by those kinds of parameter variation, you will find out for the parameter A, there is the lowest one for label 4, and for B, the lowest one for label 3, and for C is a label 2. By this way, I will give you the result. For maximum ratio for hydrogen and carbon, they can reach under the gasification temperature of 900 degrees Celsius. That means day 4. Okay, and the blending ratio is 30%. Day 3 here for the A, for the B parameter, and carbon dioxide percentage is 70%. Finally, the catalyst addition is 20%. Okay, And from the upper table, you can find out the optimal control parameter for to reach to have the result of maximal hydrogen carbon monoxide ratio. But if you look at the maximal concentration for H2, then you go to the table illustrated in the right-hand side. They tell you you need to have the gasification temperature of 800 degrees Celsius around level 2. Okay, and the blending ratio of 40%, carbon dioxide ratio 70%, and a 15% catalyst. Okay. When you have those kinds of determination on the optimal control parameter for hydrogen carbon monoxide ratio and also for maximal hydrogen concentration, then you need to confirm it again with theory. Okay, and this is the result. You can see for the maximal hydrogen carbon monoxide ratio, you can see theory, you can have a 57.4. In our experiment, we have a 56.3, very close. That means that our identification on optimal control parameter is very nice. Okay, you consider the maximal hydrogen productions. They have a slightly big difference, but not too much. Actually, the 2% variation in for the overall certified is around less than 1.5% error. Is a very still a good result, which means the optimal parameter we determine is very nice. And this tell you we try to identify the control parameter for the gasification process by using the signal to noise ratio method. Then the result is pretty much good. Now we reach to the conclusions here. Based on our three big objectives, I give you the very short summary. For the first one, we are dealing with the production of pyrolysis oil, right? And here, actually, we identify there is 4 major parameters you need to consider. One is a nitrogen flow rate. The other one is a pyrolytic temperature. The third one is a heating rate. The final one is a residence time. From our experiment, by using the Ta-Hui method, we identify the value of the quantity for each parameter shown here. A heating rate of 10 degrees Celsius per minute, a pyrolysis temperature of 450 Celsius, residence time is 60 millimeter, nitrogen flow rate is around 700 milliliter per minute. And we confirm with the theory, and they show very good match, and which means in this experiment, we already successfully identified the suitable optimal control parameters for our pyrolysis process. And later for the next one, we try to examine the combustion behavior of the blending fuel of the sludge and the heavy fuel oil. And I don't want to repeat those detailed process. Actually, those detailed stage may be changed for in different kinds of the blending ratio. But anyway, we have a general conclusion as the pyrolyzed oil contains a great amount of water and lower weight component compared with the the heavy fuel oil, and a higher pyrolysis oil content in the fuel blend will increase the frequency of micro explosion events because they have more lower boiling point, easier to be gasified and produce the micro explosion. And under the heating condition for the 500, 550, and 600 conditions, as the heating process under 500 degrees Celsius, we find out there is no ignition of the droplet, no combustion occurs. But for 550 and 600, for these two cases, actually you can have a burning occurs. But in general, most cases, you'll find out the higher pyrolysis oil content in the fuel blend will increase the combustion rate as we go through the D-square law analysis with the with the identification on the slope of your linear curve. The last conclusion focus on the co-gasification. Basically, we identify the optimal control parameters for maximal hydrogen to the carbon monoxide ratio in syngas, and the other one is the maximal concentration of hydrogen in syngas. Compare this the controlling parameter for these two targets, you will find out the carbon dioxide ratio for the gasified medians is the most important one, okay, because they are important in these two target ratios. And the second one is the catalyst additions is the second dominant effect. Actually, in our experiment, we figure out the catalyst amount, the amount of catalyst is better to control within 15 to 20%. Catalysts always play a very important role for the gasification process, okay? And this is the important finding from our experiment. Okay, I think I finished the summary on our research, and I give you some references and for your double checking. And finally, I think later on we will give you the complete manuscript for detailed discussions on each subject I present here. I'm sorry because the speaking time is short. I cannot spend too much time for the detailed discussion for the individual step. But anyway, for this paper, actually, I try to bring your attention to the application of those kinds of bio waste to different kinds of application, especially for the industry side, try to provide more energy to be used, especially those kinds of technology corresponding to so-called renewable energy. And in the process of the zero carbon emission to the 2050, actually, this is a difficult target for all of us. And we need to find additional, if you do have some additional energy coming from renewable resource, it is good to think about how to pump it and use it to produce a syngas or syn oil and try to use very efficiently. And I think this is a major goal. Now I finished my presentation here. Thank you so much for your pay attention.
Thank you very much, Professor Lin. Please give the applause for the great presentation.
Thank you.
Okay, before we continue to the question and answer sessions, Professor, may I know what is your source of the sewage sludge, from domestic or from the industrial?
Yeah, from the water treatment department. Usually for city, you know, I just mentioned those kinds of sludge sampling. Actually, we need to have a constant source. They do not change it too much. Otherwise, your composition you always change. Then because we have a good communication with the Taiwan city, and they have a different industry sites. And for the industry side, usually they have some wastewater treatment. In the water treatment process, they always produce a sludge, and we ask that they can provide those materials or raw materials for us.
So from the wastewater treatment in
Yes.
the domestic.
Yes, in the city.
Okay, thank you very much for the information. Now we are in the question and answer sessions. You can raise your hand or unmute your microphone to deliver the question directly. Anyone from the floor? Please, if you want to ask the question, deliver directly. Okay. Otherwise, Professor Lee will answer questions that were sent to us during the presentation. Okay, Professor, you can see my screen clearly.
Yes. Okay.
Okay, wait.
Is up for first question from the Johnny Aritonang from Unhan. Can all sewage sludge be utilized using some thermal conversion process? If not, which waste sludge is effectively used in this research? Maybe first question and the second question is quite similar. What is the characterization and suitable source of sewage sludge using multiple thermal conversion process? Do you want to answer one by one, Professor?
I can answer the question 1 and question 2 together because this is very important. When you go through those kinds of pyrolysis process or gasification process, you need to fully understand the property of your sludge. Okay, and you will find out you just ask me where can I get the sludge, right? And I mentioned the source is very important because for many different kinds of industry sites, because they will get involved with different kinds of productions, and the materials get involved with more complicated. For example, because those kinds of wastewater coming from different company, they will get involved different kinds of components, which means when you got a sludge, you make a pretreatment and make it, you dry it, but you need to go to check the property. So that means we go to first, for the physical chemical process, you need to check the weight loss through the thermal analysis. But you still need to do the additional work on the chemical composition, okay? Because some sludge coming from the chemical company, they will get involved different kinds of hazard materials. You need to let it go unless you, otherwise you cannot provide and produce the so-called syngas or the biofuel, because you will have some hazard materials that will produce some another pollutions. Which means when you look at the application or utilization of sludge, you need to have a certain examination on the species you may have inside of your sludge. Okay. But for our experiment, because we take the sample from waste treatment department in Taiwan City, and we know those composition do not have those kinds of hazard species, then you can safely to make it go through the physical chemical process, then produce the sludge oil. Okay. So this is important because you need to check the materials you have, the starch, the component of starch. Okay, and then go to the question 3.
The third question, yeah. What aspects should be considered to increase syngas in gasification for solid waste feedstock? Maybe some kind of the sludge, otherwise like a cake from the biomass. And also to eliminate the side reaction of the pyrolysis, since the pyrolysis is a free radical reaction, Professor.
Yes, this is a good question. From my presentation, we talk about gasification, right? And I try to give you the understanding the 4 parameters control the quality of your syngas. And why these are very important. And I mentioned the carry gas of the CO2% and the steam, because they will participate through the gasification process. And here, that means that those 4 parameters, the temperature, the residence time, and the carbon dioxide ratios, and also the catalyst are major 4 parameters. You can find it from the literatures. But let me see, if you try to increase the syngas, okay, as you mentioned here, you need to know there's a coupling between the parameters. For example, I mentioned in the final conclusion that the most important parameter is the amount of CO2 you have from the gasifying the gas, okay. But you cannot just increase the ratios, because those kinds of parameters will have some coupling effect together. Okay, but you need to find out their relation. Why this is why we working on those kinds of identification on the experimental condition by using the culture method to identify it. Okay, and yeah, there is an important thing is how to eliminate the side reaction of pyrolysis.
Yes.
You know, the pyrolysis, because you try to produce the pyrolysis oil. In the pyrolysis process, actually you're heating it, right? When you add the energy into it, you will find out if temperature too high, they will produce the process go to the combustion. Okay, combustion means that they will go to the products. You try to prevent it. Therefore, usually the control of your carrying gas, usually we use the nitrogen as the carrying gas. Sometimes people will use air, but those kinds of oxygen inside air will try to reduce the because they will bring it to the combustion process. That means that you need to control the heating rate, okay, and you try to prevent the direct reaction with oil, okay. Because you mentioned it's free from the radical reaction, right?
Yeah.
We just go through
Since
pyrolysis.
pyrolysis,
We don't want to go
Professor.
to the combustion process. Yeah.
Yeah, because we don't want the reaction will be the free radical reaction cannot be predicted the result of the gasification. Okay, Professor. Before we move to fourth question, since you mentioned that the catalyst, actually, I also have conducted the research on gasification, converting bagasse, sugarcane cake into gasoline by using ferrous as material bed, that also as a catalyst in gasification process. Thus, in your research that I read, you use quartz as bed material in your fluidized bed. Is that right, Professor?
Yes.
Is
But
it the quartz as also as a catalyst in your process?
You mean the pyrolysis process? No, I mean we put into the
Gasification.
No. Quartz plate is just to maintain it for the they can induce the high temperature, not a catalyst.
Okay. For the catalyst, what do you use for the catalyst?
Yeah, but for gasification we use the for gasification we use a catalyst, but for the pyrolysis we do not use it. Yeah.
Oh yeah.
What
kind of the catalyst, Professor, that you use in this study?
It's olefin.
Olefin. Actually, we olefin. And let me see which page. Let me double check. I this actually we just buy it from for the gasification. Let me wait a second. Let me check. Methodology. Oh yes, we use the olefin. The amount. Olefin, yes. Olefin. We use olefin as the catalyst for the gasification process.
Okay, olefin. Okay, so it's a hydrocarbon.
Yeah.
Okay,
And
thank you very much.
the percentage around the beta one is 15 to 20%, 25%. Yeah.
Okay, so the quartz is just bed material in the reactor.
Yes.
Okay, thank you very much. Because
the bed material, yeah. But
yeah,
you know,
because in my
different kinds of catalysts were used for the different kinds of sample. I'm not sure because I'm not my major is not a chemical engineer, but sometimes they will have a different kinds of suggestion using different kind of catalysts for different kinds of waste material. Yeah.
Yeah, because sometimes the catalyst will be determine your product.
Yeah.
Okay, Professor. So we move to before we move to the fourth question, Mr. Johnny Aritonang, is that quite clear for you, the answer from the professor? Mr. Aritonang? Is it clear enough? The answer? Okay, I think the answer from the professor is quite clear. So, Professor, for question from
Okay.
Mr. Ramon Lapisa, one of the center, our research center staff, how to manage the emission from the combustion from the waste fuel?
Okay. Yeah, this is a good question and a difficult to management because the waste fuel means the fuel coming from the waste, right? As I mentioned, the composition of your material or your raw material is very important. If you already contains a certain hazard species, there is the two way to eliminate it. The first one, if you go through the gasification, then you can have a filtering. For example, people understand, for example, for the coal gasification, right? For coal, when you go through the coal gasification process, you will produce the SOx or certain amount of NOx, and they always have an upstream pre-treatment. When you have a syngas, you have those kinds of gasified gas, then they will have some denox or desox at first. Then they clean it, then you just have the carbon monoxide and the hydrogen or methane left for the syngas used for your application. This is an upstream management. But in general, for the gasification, people try to eliminate those kinds of hazard products before the application. And they do not want to management after the combustion process in the downstream, because they will you still will go back to the recent fire the power plants. Okay, then usually we try to eliminate those kinds of the hazard emissions before they go through the process or they go through the final products. Which means for in response to your answer, it is very important to choose the waste materials before you try to think about to produce the
exactly.
gas or go through a different process. Yeah, this is very important. Actually, we go through the gasification process or a pyrolysis process, and you try because all the component you may have in your products is influenced by the original composition of your materials. And those waste materials always contains a certain amount of hazard species. You need to prevent it.
Okay. There is a follow-up question from also from the Ramon Rapisa, Mr. Rapisa. Which one is the more potential to be developed between domestic waste or industry wastewater? Which one is the more potential, Professor?
Sometimes city waste has a low volume, has a low heating value. Is that sometimes if you based on the energy consideration, you will try to get the industrial waste. For example, you may have some residues oil from the petroleum company. They will have a high thermal content to be converted. And for industry, actually, because those industry has a different kinds of individual purpose, and they were separate and easier to consider for a given waste. But for the city waste, usually the composition are quite complicated, and also the heating value is low. Therefore, the value for producing the biogas or pyrolysis oil has less.
Okay.
So it is better to more concentrate from the industrial waste. Easier.
So industry waste is more easier.
I mean, it's I can also easier, but it's more effective and will give you the more value. Yes.
Because they have the certain the composition and also the permanent composition different from the domestic wastewater.
Mhm.
It has a different, everyday different composition.
Yes.
Thank you very much, Professor. So we can move to another question, Professor.
Yes.
Okay. Fifth question, is there any pre-treatment or treatment prior to gasification to decrease heat and energy consumption in gasification process except dewatering? Is there any pre-treatment except dewatering, Professor?
This is also a good question, because we try to produce bioenergy, right? And this is
Bioenergy, yeah,
additional
right.
achievement. But in the process, for the pyrolysis process, for the gasification process, usually you need to provide energy, right? You need to heat it.
Yeah. Yeah.
Which means when you go through,
You need to heat
for
it.
example, in our study, when we go through the identification from the control parameter, then the next step is you need to count how much energy you use for this gasification process. Then you need to evaluate economically how much you input and how much gain. Okay, so this is a good question, but you need to have some energy and balance analysis and convert it to the money. How much money you need to? Yeah.
We should have
means
economic
the cost.
evaluation.
Yes, you need to have some cost evaluation.
Yeah, cost evaluation.
Even from the
Maybe-
energy. But in
Yeah.
general, the final product for the energy actually is larger, usually should be larger than the input energy for your process. Otherwise, you don't need to produce those kinds of biofuel, right?
Yeah, biofuel. Right.
Yeah. So usually,
The-
we do have extra energy can be output.
Yeah. Regarding the prior for the previous question, maybe this next question is also have the follow up the question. Multiple thermal conversion process also suitable for applying in biomass such as solid waste or cake from crop extraction. Such as you also use the PKS palm kernel shell, but you use shell, right? How about the cake product from the extraction, since they have the lower moisture content compared to the sludge?
Sure, this is
Such
good.
as,
Yeah,
palm oil
yeah.
cake.
Yeah, crop extraction. I think this is
crop
good,
extraction.
but because in my presentation, I just give you the example, more focus on sludge, okay? And the sludge has its own natural property, but for different kinds of waste, they may have a more energy be released. There is another case. I just give you a sample case for the gasification process and pyrolysis process, and the focus on sludge, and this sewage sludge has a large water component. If you look at for the coke or maybe sugar cane, those kinds of material, you can have even better, even better output. Yeah.
Yeah. Thank you very much, Professor.
No problem.
Next question, Professor. What is significant to determine combustion characteristic of your product?
Yeah, in my presentation, I tell you for the pyrolysis oil, we try to look at the burning intensity since we look at the liquid fuel, right? And we try to bring the commercial heavy fuel oil because people usually to use this. And those heavy fuel come from the petroleum industries. But for our case, we go through the pyrolysis on the bio waste, and then we try to compare the combustion intensity, and you can figure out in our experiment they can justify those kinds of combustion characteristics based on the droplet burning. And you also can, if you want to go to the further judgment, you can apply into your engines. But sometimes people feel that the pyrolysis oil sometimes will damage the engine, gasoline engine or diesel engine you use. Depends on the compositions of your biofuel. That this is another. This is the major concern I always mention. If there is some because sometimes they will produce some erosion problem. or they were because they sometimes there were some contamination and they will block the injectors and produce the failure of the engine. Now you need to consider the real application. But for the pyrolysis oil from our experiment, we can identify the combustion characteristic. But for the gasification, since the major component for the syngas usually composed of the hydrogen and the carbon monoxide and a small amount of methane, actually you can justify the combustion characteristic based on the composition of your syngas you have. It is very simple. If you have more carbon monoxides, then the heat output will be increased. Or you have more hydrogen, the flame speed will be higher. Those kinds of characteristics can be justified based on basic combustion characteristics of those gas. Okay, carbon dioxide, carbon monoxide, hydrogen, and methane. Okay.
Okay, thank you very much, Professor.
And this is very important because
yeah,
you
very important.
you need to justify the combustion characteristic. Yes.
Yes. Okay, Professor. The next last question. Actually, many questions come to our committees, but this one is the last question. Please, Professor.
This one, it is hard to me to answer. We never use the response service method, but since we check the report and the literature, find out Ta-Hui method may be a good one because we have so many control parameters. You cannot vary too many factors. Then we learn from the some reports from Ta-Hui and we check it and we find out the identification on optimal results is fit very well with the theoretical estimation. Then we use the Ta-Hui. I'm sorry, I do not have experience by using those response methods, and I cannot give you the answer. Maybe there is a good thing I will think about. Can we use the method? Up to now, actually, Ta-Hui method is very good for us because the result is quite is excellent. But anyway, we will think about that method. Thank you for your suggestion.
Thank you very much, Professor. Okay, actually there are so many questions, Professor, but because the time is over for the question and answer session. Thank you for the great presentation. These articles will be published in the next issue of our Teknomekanik journal. You can access our open journal and welcoming to chat this article and other articles in our journal related to your research. Link of our journal is stated in flyer. So
yes,
don't miss our flyer and keep up for you our flyer.
Thank you. Thank
you, Professor.
Thank you so much. Thank you.
And don't forget to subscribe our YouTube channel, stated also in the flyer. It is our happiness, Professor, to have you here with us, Professor. We would like to thank to you for your contribution in our event and also our journal. Please, we have the link of your certificate. Please.
Okay.
I'm sorry, Professor. Wrong technical. We already prepare your certificate and also for other audience. This is your certificate, Professor, and will be sent to your email. Thank you very much.
Thank you so much. Thank you so much. I appreciate.
Okay.
Yes.
Thank you very much. We also happy for have you here in our symposium. We wish that we can have a collaboration between Universitas Negeri Padang and also your university, such as research collaboration and also student exchange, PhD program for our lecturer, visiting professor, and something other collaboration in the future.
Sure, no problem at all. I'm happy to cooperate with you. Yeah, if you have any requirement, just let me know, and we try to help to think about how to cooperate between our institutes. Okay.
yeah, our institute and also our research center.
Sure, sure, sure.
Wish you all the best and many success for your life, Professor, and also for your students, for your postdoctoral in your lab and also in your institution.
Thank you.
For the audience, actually, we have last symposium in the 29 December. This is our last symposium in this year. From the speaker, Professor Bagdaulat Kenzaliev from Sabayev University, Kazakhstan. If you have the time, you can join in our symposium, Professor, and also ask your student to join with us 29 December. Okay. For the link of the registration, we will share, and also we will share your the poster like the previous symposium. Thank you very much, Professor.
Thank you.
Okay, we also would like to appreciate all the audience for your active participation in this event. We apologize on behalf of the committees is any lacking in our event, and also hopefully this symposium will be beneficial for everyone. Finally, it is end of our symposium. Thank you all and see you the next symposium. Bye-bye. Wassalamualaikum warahmatullahi wabarakatuh. Sema arigato, Mr. Anas, Fauzi Anas. Pak Anas, thank you very much, Pak Anas, for this collaboration. Maybe also then in the future we can also have the collaboration, another collaboration. Thank you once again, Professor Ta-Hui Lin, for the contribution. Bye-bye. See you in the next symposium. Bye-bye. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Okay, this is end of our symposium. For the audience, the link of the certificate will be sent to your email as your email in the registration. Thank you very much. Oh yeah, if the link of the certificate cannot access in your inbox, you can open or check your spam. Thank you very much.